So now we're gonna work out a problem testing the proportion but using the critical value approach along the p-value approach, and just show you how the critical value approach works. A factory claims that less than 8% of its items are defective. A quality control managers take a random sample of 200 items and find that 10 of them are defective. So if you want to write the null in the alternative will be that p less than 80%, and the null hypothesis will be p greater than or equal to 0.08. But if you are taking my section online, you know that you only can put an equal sign in the null hypothesis, so you can replace, this sign right here with the equal sign. But the alternative has to be either less than, greater than, or not equal to. It's always one of those three. N is 200, the number of observations, and 10 of them are defective is the number of successes, X. And alpha here is given to be 5%, and we want to do it using the critical value approach. So here is how we do this using StatCrunch. So we go to stat, proportion stat, one sample with summary. Let's lower it a little bit and show you some stuff here. Number of successes is 10. Number of observations is 200. P is 0.08. And we need the alternative sign, which is less than. We need to show the critical value because I want to show you how to do that, solve this problem using the critical value approach, and make sure to put the right level of significance, which is 0.05. Compute, and then if I show you the screen, the test statistic Z is negative 1.56, and the critical value is negative 1.645. And look at the p-value, it's 0.0589. So we got step number 2, the test statistic. Step number 3 is to sketch the rejection region using the critical value method, which I'm going to show you how that would be like. So the test statistic is negative 1.656, and the critical number is negative 1.645. So you see, this is a left tail test because p is less than. With less than means left tail test. So you draw the normal curve, you put 0, 1, 2, and negative 1, negative 2 here, and then the negative 1.56, you put it on the number line. It's right here in red. And you shade to the left, just of that, because this is a left tail test. So you shade right here. And then you bring the test statistic, which is negative 1.56. Sorry, the critical number is negative 1.645. So the red one is negative 1.645. You can see it's in red. And then you shade to the left of it. Then you bring the test statistic, which is negative 1.56, and put it in the number line. If the test statistics end up in the rejection region, then you reject the null hypothesis. If it ends up in the non-rejection region, you will not reject the null hypothesis. And since negative 1.56 is bigger than negative 1.645, not much bigger, look at the difference between the two, then in this case you fail to reject the null hypothesis. So test statistic is negative 1.56. The critical number is negative 1.645. This is a left tail test. Because the test statistic is bigger than the critical value, you fail to reject the null hypothesis, as I explained a minute ago. And if you fail to reject HO and the claim is in H1, you cannot support the claim. So you say there is not sufficient evidence at the 5% level of significance to support the claim that fewer than 8% of the items are defective.